Hi, and welcome to this talk by Felix Baudry. We're looking today at the technical object of a PCB. And, well, a PCB is just a type of electronic circuit. And we're also going to look at electronic circuits in general. I'll be approaching the subject from the angle of the cultural and technical object. It's a concept brought by Simondon, a French philosopher, and he was interested in the technical object in the sense that it was, for him, a type of object that should be regarded just as important as any other cultural object. We could say that in many instances, a technical object like a PCB is not really the same as a, let's say, a painting by a master of oil painting. But for Simondon, the technical object should have been something that people regard in the same importance. They should put value onto the technical object. So for Simondon, the technical object is something that is part of human culture. He thinks that we should learn about technology and that we should kind of reclaim the technological object in order to reduce the alienation brought by new technology. Meaning that in the past, the humans were kind of close to their technology. And there's some sort of disconnect now with the newer technologies. And since we don't understand the way they function, well, we have a harder time to connect with it. So my goal with this project was to kind of go into the subject of the printed circuit, but go into the cultural aspect of it. Try to find the human that create the technical object, and to really show that this is not a society of the machine, but it is more a culture of individual wielding these technology, and that there's a craft that can be appreciated with electronic circuits. So I approached this task by making a diagram of all these different ways to make circuits. I apologize in advance for the folks who are expert in the matter and that knows all these things, and I'll probably make mistakes along the way, but this is like an overview, a broad overview of the whole, I would say, ecosystem of ways to create these circuits. Yeah, and probably Simondon would kind of like the idea of having kind of evolutionary tree and talking about ecosystems, because he speaks of the technology in terms of evolution and continuity. So yeah, so I'll start at the top of the diagram here. So at the top, I put the electronic circuits, the main subject of the talk. And if we go through that branch, we can see the keyword dead bug. Yeah, dead bug refers to the way an IC chip is sometimes soldered to other component. So it refers to the way it lies upside down, stick to a copper clad board, and is connected to different electronic components. This is a style mainly used for prototyping, and we can see example of this into this project. The other word that is closely linked to dead bug is ugly, and it is not to say that it is ugly literally, because yeah, some people find it ugly, but it is in some way chaotic, but it kind of just makes it also an art, because you need to connect all these components together on a board and make it very cheap and quick, and it is somewhat mesmerizing to see all these things in a very chaotic mess produce a very useful and organized object. So I put names and person into the diagram to show that these ideas and these construction really come from people, and these ideas are shared on the internet, and people learn about it, replicate these projects, and share everything on their designs. And one of these people, the first one I want to share with you, is Roger and Wes Award. And they made this project called the Ugly QRP transmitter. And a QRP is a type of amateur radio. It is called ugly not because the box itself is ugly. It refers to the way the circuit is constructed. And the goal was to encourage people to try different things with their circuits and to make circuits quickly in a weekend. So he produced this article on how to create this amateur radio for very cheap with spare parts that you have in your drawer. And if you want to find out more about Roger and Wes Award, I'll put links to every topics that I will be addressing in this discussion, and you can find them all in the description below. So I kind of linked this amateur radio to this other one because I couldn't find good image of what it looks inside, but it's basically probably something a little bit like this. So this is the Funster receiver by this guy here, Vasily Ivanenko. And again, I must apologize. I hope I don't offend anyone. I will be saying a lot of name in different language because these people are all over the world, and I don't know all these pronunciations. So I hope they won't be mad about it. But yeah, you can see all these components soldered directly to a copper-clad board here, and the copper-clad board here is like the ground plane. Every connection to ground is made on the board, and every connection in between the parts are made kind of flying in the air. Yeah, this is not the most sturdy way of constructing something, but it's quick, and it's easy to kind of put together in a weekend. The main thing though with this type of construction is you can't really make stuff that you want to carry around with this because it might like be shaken, and if it's not really well anchored to the board, it might get shifted and you might have a short circuit. So this is good for an AM radio, and it's it's the type of construction that you see a lot for amateur radio. Um, so if we continue down this path of ugly construction, we can find another style, that is the Manhattan style, and it's like a little bit like the ugly construction, but it's somewhat a little more organized. And the key difference is that you have, I'm gonna try to zoom a little more. Oh, this is ugly, so I'll zoom out a little bit. But yeah, this is a circuit by Tetsuo Kogawa, and it's called the simplest FM transmitter. And what he does is he uses little pads of copper clad that is glued onto the main board, and in this way you can connect the positive leads or the other connection that are not the ground to these pads, and the ground connection are still on the main copper clad pad. And this way the circuit is a little more sturdy and a little more clean to look at. So it looks a little bit like a city skyline when you have these stacks of little pads rising above the copper clad board. So yeah, that's why it's called Manhattan. So I would encourage you to take a look at his website. I'll have the link in the description, and it's very interesting. There's the micro radio manifesto. The idea is to make very low power FM transmitter and to broadcast the radio like in a 30-meter radius, something like that. It's very, very localized radio. It's a very interesting idea. So another way, so these circuits are built on copper clad boards, as I said, and so they are into the circuit board category. But before you make you want to commit to a circuit, sometimes want to prototype this circuit onto a non-permanent prototype board, and these are often called breadboards. So I kind of wonder why they call it breadboard. And I found online this video from Collin Cunningham. This project is called The Real Breadboard. In this video, he explained how people used to prototype their circuit onto pieces of wood with nails and copper wire attached to the nails. And one of the interesting things about prototyping in that way is that you can create your circuit exactly like your diagram. So yeah, I think that something that is interesting with this weird word here, breadboard, is that you can start to see a kind of a historical legacy forming. You know, it leaves a trace in the language. At this point, nobody uses a piece of wood to prototype their circuit, but they use still something that is called a breadboard, even though it's not a breadboard. And it's a little bit like you have on a computer a folder. It's not a real folder. You know, you don't put sheets of paper in a folded bigger sheet of paper when you put something in a folder on a computer, but you still use the word folder because it's a good abstraction of what you want to do. We have the printed circuit board. So this was initially the subject of my research. I wanted to know more about the printed circuit board, and I kind of started to understand that a printed circuit board is somewhat it's a paradigm in circuit construction. So This means that it's the thing that people do right now, but it evolved from something that came before, and it will be transformed into something else in the future. So that's why I started to expand my research. So the main traditional material for the circuit board, as I discussed, is the copper clad. It's an epoxy and fiberglass composite board, and it's used in like artisanal construction, like the Oglier and Manhattan style, as a big ground plane and something just to attach the part to. But it's also used in industrial processes, and one of these is the subtractive manufacturing process. And what you do is you put the copper on the fiberglass board, and you etch the copper away. That's why it's called a subtractive manufacturing process. It's a way to construct circuit by taking away the material. You put a big sheet of copper and you etch away the part you don't want. And this leaves you with a board looking a little bit like this, without all this green resin. You would see the copper traces underneath. So yeah, this is the Arduino board, and I put the Arduino just because it's a very well-known PCB. For now, it's the main way to produce a circuit board. It's to etch away copper, but there are also other ways that are kind of emerging now. It's like this thing, flax fiber and resin composite. So this is something that is new this year. It's the Soluboard by Jack Ehring. He's making this new type of fiber board that is water dissolvable. Well, anyway, it dissolves in water. And the main reason why you would want to dissolve a board into water is that it will allow you to take all these parts away from the soluble fibers and recycle them. The only way to really recycle a commercial board like this is to kind of crush the board and burn everything and gather the rare metals that might be left after the process, and a lot of the metal is destroyed in the process. A lot of the component cannot be retrieved, and this is not very effective process. It wasn't created at first with recycling in mind. So in a way, this is already a kind of small paradigm shift. The technology is not very established yet. It's you can't really buy it now, but it's very promising technology, and it uses a different way to put the traces on the board. So you can see they are not copper. It's a different process. So still in the we're shifting category now. It's additive manufacturing. So these traces are silver ink traces. It's another way to create these connection. And these silver ink traces are used in different process too. It's the main way you do the connection when you want to 3D print a PCB. So I put here an example of what you can do with a 3D printed circuit board. So this is again very experimental. And Here the difference between the object and the circuit kind of blurs a little bit. We could say that it is kind of converging towards being one unit. You know, you don't have like a circuit on a board or an object with a circuit inside. You kind of have a circuit object all at once, and it's kind of a concept that is going to come again in this talk. We see a lot of these artist project and different ways to create electronic circuits that kind of leans toward becoming a circuit object more than an object with a circuit inside. And well, this reminds me a little bit of the Simondon example with the car engine. You know, like an old car that you take the motor out. But you can see on the internet like these creation that people do. In his example, he's talking about a old motor car that you can put inside a boat and the boat will run fine. But if you have a new car, the motor is so specifically designed for the purpose of running the car that it's no longer able to perform any other task. So at some point you have like this concept of something that is normally pulled by a horse, and you say, oh, I'm gonna make this horse carriage into an autonomous horse carriage, and you call it the automobile, and it's carriage with a motor inside, an actuator or something that moves the carriage. At some point the car becomes an idea of a car needs a motor. It's not just a carriage with a motor inside. The motor becomes part of the car, and it's no longer two things, you know. It's one paradigm. And it's a little bit the same thing here, where you have like this, an Arduino microcontroller. It's something you can put inside a design to control different things and have different sensors plugged on it, and you can create, I don't know, almost anything with it. You can monitor your plants, see if they have enough water and everything. But if you unplug everything, you put your Arduino into another project, it's gonna do anything you want. You know, it's like a module. It's easy to take it out and use it for different things. But here it becomes a little bit more embedded. You know, the circuit with a 3D printed circuit object would be more kind of a one unit, you know. And the main goal with making these 3D printed circuit object is to have something that is designed specifically to do one task and only that task. Well, another way to look at 3D printing technologies and circuit is a more, well, I would say maker approach to it. It's the integrated wire guides. It's a little bit like wire sintering. Here we have a fine example of this. And it's a personal inspiration for me. It's the 3D PC Boy. So it's a 3D PCB Game Boy. And yeah, you can see that there is modules, Arduino modules in it. There is also the circuit board that is kind of embedded inside the object. All the connections are there. And this was made by Johan von Konow. His project is really interesting, and I encourage you to go check his page. So as I was saying, these are kind of Arduino compatible modules, and you can see here this type of modules that can be plugged and unplugged and reused for different purpose. In a way, this is a different approach, and it often, for environmental reason, it's better to have something that is modular, just because you can reuse the components for different projects. So if you're making like something that is more small batch, that might not be used for a long time, it's better to have modules so you can recycle the module or reuse them. So it effectively upcycle the modules. So for artists, it's very common to use these types of little sensor on a board. And yeah, we can see how it's implemented in this 3D printed circuit here. So if we go up a little bit, we can talk about the way these circuits are designed. So the design tools here back in the days were drawn by hand. So all these connections were drafted on a vellum paper. The layout would be taped with stickers. So all the little pads would be the exact same size. And this tape was like a 1/4 inch wide, and obviously the circuit board was not this big at the end. It was way smaller, so it was a photographic technique to reduce the size of the design. So the precision was increased in that way, so you could get away by drawing it by hand, because you would draw it very big and then reduce the size. And I put it mainly to put an emphasis on how all these technological things that we see sometimes as machines and non-human and irritating are actually designed and conceived inside a human mind, and they are made to be handled and to be used by humans. So it is a human activity, you know. Now we're obviously not drawing these by hands anymore, but some still do, and it's something that I find interesting with this old culture of electronic circuits is that there are still people doing it just because they like it, you know. They do it like an old grandpa doing woodwork in his basement, you know. They just like to work with the electronic circuits, and it's kind of a creative activity. So I put KiCad. There are many different software that are used to do these very complex traces, and yeah, it's a little bit more robotic, you know. All these lines here, you can see how fluid they are, and you can kind of see almost they seem almost organic in a way. As here they are more square. The people who make the boards to try to go around that, and some artists actually use these software in ways that were not intended to create different looks for their board. And one of these guys is Saar Drimer. So I put him in the screen printing category because I think his board are very beautiful, and they use a lot of screen printing. So screen printing is a way to put graphic on a circuit board, and you can see here many colors are used. You have red and white and green, and these colors are applied through a silk screen. And with many application, you can have different colors layered onto another. And he makes a lot of boards that are pretty useless, I would say. Not useless entirely. They kind of blinks, or they have like tiny lights, and they are kind of just art pieces, you know. They don't serve any real technological purpose other than showing that you can be creative with this medium. You can express your humanity through the production, the industrial production of a circuit board. So he made his own software. So you could not like just create something like this in a standard software like this. Well, this is more like a standard way to lay out components, and you cannot really deviate. But here he has made a custom software to transform the vector files like in Illustrator. I think he uses Inkscape. It's in a way a work that subverts the industrial process of making circuit board to create very beautiful and attractive art pieces. And some of these boards are actually, they don't have any circuits at all. This is just like a nice piece of screen printed, produced with the same technologies and tools as a engineer of a circuit board would use. And well, I find it very interesting that it kinds of subverts the whole process of making an industrial circuit board. And you can see that he draws his design by hand at first. Very nice work. So if we go back up, I think I'm gonna go back all the way to the top and follow the other branch of my diagram. So we can encounter here a freeform construction. So this is a style that is kind of old and kind of new. It has a kind of a renewed interest now. It's somewhat related to Deadbug, because Deadbug is, again, you take a chip and you solder parts directly on the leads of the chip. And often they are glued on a ground board like this, upside down, but they can also just float in the air. And the freeform construction style is it's a little bit part art, part sculpture, part electric circuit. So here it's the Crystal McCoy freeform headphone amplifier by Rupert Hurst from Talon's Lab. This circuit is just to amplify a signal for your headphone, but you know, it's not the most efficient way to create a circuit, but it's definitely one of the most beautiful circuits out there. And you can see here you have like a dead bug style of construction, where you solder the parts to the lead, but it's definitely not the ugly style of construction. You know, it's very clean, very organized. And what he do is he's using copper wires here. Sometimes they use also brass, as you'll see in other works. And they use sintering methods, so like you know, these chairs that have metal tubes, bent metal tubes to create the legs. It's a bit like that. You bend the wire. That way you can create a circuit that is fully 3D, free form, as they say. It's a very appealing circuit. And again, here you get kind of away from the usual paradigm of putting a circuit on a board and putting the board inside a case and using the object as a something that is abstract. Like, even though you don't know how it works, you kind of understand that there is a link between the object and the circuit. There's a task that is performed by the circuit. It's something that often designers say forms follow function. Here the function is the main thing and the form is dictated by function. Some could argue that like the function is also to be like waterproof and practical, but yeah, it's definitely an appealing design and one that blurs the line between circuits and object. Another one here that I'll link to the freeform construction is the LED jewelry badge. So badge is a term used a lot in circuit design. These kind of tiny circuits that you can wear on yourself is often called a badge in hacker communities and maker communities too. Sometimes you have to make your own badge when you enter a convention, and you go around to the different booths and you collect the badges created by all the participants. Seems by looking on Instagram that there is a lot of people interested in this type of object. Usually it's PCB, as it is considered like a rite of passage to design your own PCB in these communities. But here Jiri Press makes his circuits entirely out of brass wire and tiny LEDs, and they are powered by a coin cell battery. And he makes these very nice videos of him constructing the object and showing how it's done. It's very open and welcoming. It's very different from other types of circuit because you see he's holding the circuits directly. He's touching the wires. They all conduct the electricity. So you're not often in contact with the circuits. And here we see everything, and everything is beautiful. It's the aesthetic of the technology that we appreciate here. And it's a work that is relatable. You don't need to be a geek nerd of electronic circuit to appreciate the beauty in his work, and that's why I put him on the top here of this beautiful diagram, because I really like his work. And if we go down the path of freeform construction, we'll find the work of Mohit Poite. I'm not sure how to pronounce his name. I'm really sorry if I don't say it correctly, but yeah, he's making anthropomorphic sculptures by using a combination of techniques and circuit making skills, I would say. And here we have two of his projects, the Chin 2 and 7 Segment 2. And just like Jiri Press, he's using brass wires to create the connections, but he's also using printed circuit boards. So I put a link to the sensor modules and breakout boards from Adafruit Industry and Arduino to his work, because, well, he's using it. And here again, you know, the object is the circuit, you know. So you don't need to hide it. You don't need to shy away from the circuit. And this is a trend that is seen a lot these days in product design. We now see a lot of synthesizers now show you the circuits. I have a keyboard with a lamp amplifier, and there's like a little window so you can see the electronic component, the little lamp that lights up. It's a bit like yeah, you want to show off the circuit. You want people to understand the technology that is inside, and it's yeah, it's a shift. And I think that if we want to understand culture today, we kind of need to have this knowledge of technology and how they function, how they are made, and why they are made that way. And once you understand a little more the lore behind these technologies, it's easier to relate to the human side of these technologies. We know, like, we know the basic technologies. We know how a hammer work, and we regard the newer technologies like computers as something that is not us, that is a machine, that is non-human, and we don't see these work as valid works of art often because we don't relate to these communities. We don't have the knowledge to really understand why they are made that way, why it is, I don't know, a great object, a smart object, or a masterful technique. We just don't have the technical knowledge for that, and it's kind of hard to get it. You need to investigate further, and yeah, this is more my opinion, my personal opinion, but I think these knowledge should be taught in school. We learn a lot of things about painting, science, and philosophy, and not a lot about the technical achievements of humanity. But humanity always expresses itself through the objects that are created. You can learn a lot about a culture by taking apart or analyzing the objects it produced. And if you're interested in the technical knowledge of a society, you're also interested in what this society does. And in a way, if we look at the way we produce PCB here, we can learn that the society isn't very interested in how we pollute with our technologies. But if we look at this one, well, you can see that it was something that at some point started to interest humans, you know. And so, yeah, one of the quotes I really like in the works of Simondon is, in order to restore to culture the truly general character it has lost, one must be capable of reintroducing an awareness of the nature of machines, of their mutual relations, and of their relations with man, and of the value implied in these relations. This awareness requires the existence of a technologist or mechanologist alongside the sociologist. And really, this is a bit what design, industrial design at least, have become, where you have in an artist that is really interested in the technology that produce the object that we kind of buy every day, and also the human side of things, how we use these objects, what are their impact on society. I think is very well aligned with Simondon's point of view. So yeah, I hope you like this this talk. I've put a lot of effort in this research, and I hope you'll have a like a newer point of view on electronic circuits, and you'll see that it's more than just an industry. It's also a culture. It's a human activity, and it's something that we would all benefit from understanding more. So, as I said, all the people in this diagram are in the links below. I encourage you to take a look at these articles, these web page. It's very interesting. Now I feel confident going and designing circuits for my own project and my own practice. So thank you for listening. Goodbye.